Who here is from outside of Pasadena? Who here lives in the greater Pasadena area? Okay, so we got a nice mix. So I think this talk will be a little, it's high level, it's not going to be super technical, but it's going to be a nice ride down memory lane for at least some of you guys, and hopefully a good overview of what Pasadena and technology has to in store. So I have friends who are members of the Athenaeum, and the Athenaeum is a club, probably one of the oldest clubs here in LA, right next to it's in Caltech, and Albert Einstein was one of the first club members. And I was there, this was maybe 3 summers ago, and there was this outside bar, and there was this professor, female professor, at a table with all her students. Then I see her get up to the outside bar. She comes back carrying 2 gigantic steins of beer, right? It's like straight out of Oktoberfest. And my friend next to me, Beth Kuchar, if you're a local here, she's a chairwoman of Innovate Pasadena. She goes, Gene, you know who that is? I go, no, that's Frances Arnold. She just won the Nobel Prize in chemistry. She's the first female Caltech faculty to win a Nobel Prize. So fast forward to this year, my wife and I, we became members of the Athenaeum, and there's a nice indoor bar in there, and they have a wall just of all the Nobel laureates. And there's Frances Arnold way on the right side, or left side for you, the sole female Caltech faculty. But this past year, so she won 4 years ago in chemistry. This past year, a couple well-known folks in the AI space just won. John Hopfield, along with Jeffrey Hinton for neural networks. And John Hopfield is also a Caltech faculty, so his picture will be in there. So just to let you know, like here in Pasadena, we have the 2nd largest concentration of living Nobel laureates outside of Switzerland itself. So with that in mind, that kind of segues into my talk about AI LLM and how it corresponds to search. So I'm OG search. I was in a little company here in Pasadena in 2001 called GoTo.com that became Overture, and it got acquired by Yahoo in 2006. But of all the companies I've been in, 3 or 4 of them are here in Pasadena, local to Pasadena. So I think there's the internet at large, and search, and now LLM has a lot to thank for, I think, for the folks here in Pasadena, and I'll kind of go over them. So specifically about GoTo, as I mentioned, it was that I was in. I joined in 2001, but it was founded as an Idea Lab company. And Idea Lab is like the original incubator. Y Combinator up north is based on Idea Lab, and an Idea Lab was founded by Bill Gross, who's a Caltech alum, and it was founded like '96. And back then, in Web 1.0 era, Idea Lab created over 150 companies. City Search, Ticketmaster, Pets.com. I think the famous sock puppet that you guys are aware of from the Web 1.0 era, that came from here. So I joined in 2001, GoTo.com, and at that time it was already doing $500 million in revenue. We became Overture in 2002, and we became a pure sponsor search company. Before we were a portal. Back in the Web 1.0 era, there was all sorts of portals. Yahoo was a portal, AOL had a portal, so forth. So was GoTo. So we became just pure sponsor search, and we were acquired by Yahoo in 2004 for $1.7 billion. At the end of that year, we were already doing $2 billion in revenue. They moved us to Burbank in 2005, so I was commuting from here to Burbank. So Google AdWords was a blatant copy of the Overture, and they launched in 2002. It took them only 2 years. They were doing $2 billion in revenue by 2004. So Project Panama was launched by Yahoo in 2005. It was a rewrite of the Overture search engine. And so believe it or not, Overture, in our peak, we were doing 2 billion searches a day, serving 2 billion search results a day. It was written in Mod Perl. Mod Perl, and I tell a lot of, Mod Perl is the the bubble gum and duct tape that keeps the internet together. And here's a good example. It was written in mod Perl. And we had J2EE, which was open source at the time before Oracle took them over. We were running on RHEL, Red Hat. We rewrote it to C++, Tomcat, which is open source, MySQL from Oracle database, which I would never use again, and FreeBSD. Yahoo was a huge FreeBSD proponent. We had a lot of core contributors at Yahoo and FreeBSD. That got us a 30% revenue uplift. It took us 3 years. It was 3 years, 500 engineers. I call it a death march. It was a do or die competition against Google. So it got us a 30% revenue uplift to 3 billion, from 2 to 3 billion, which in any other industry would have been fantastic. Google AdWords in that time went from 2 billion to 20 billion in 3 years. So that's what happens when you compete against the 800-pound gorilla. So by 2008, 2009, a couple things happened. One, Microsoft famously offered the $45 billion buyout deal that Jerry Yang said no to because he wanted to stay independent. And then, unfortunately, search just kept declining in Yahoo. So Yahoo gave up search, and we outsourced it to Microsoft. So that's kind of the search history there with GoTo, Overture, and Yahoo. So after I left around 2009, and I joined, me and a lot of my Yahoo folks joined a local search company called Yellow Pages, which was acquired by AT&T Interactive. So in 2009 or 2010, I had a chance to visit AT&T Labs in Morristown, New Jersey, and AT&T Labs, or the old Bell Labs, is like the original incubator, right? The transistor, black hole theory, geosynchronous satellites were all invented there. So I say this because I visited Shannon Labs, which is the picture of, and so Claude Shannon basically is the creator of information theory, and that is the basis in which then information retrieval comes from. As a side note, also sat in the office of Dennis Ritchie, who just passed away prior to that year. And Dennis Ritchie, hopefully everybody here knows the name, but creator of Linux, or of Unix and C++, or sorry, C. Unix and C, so, you know, two rather important things here in the open source foundation. So from information theory to information retrieval, IR is basically the basis of search. And it's the process of finding and presenting relevant information from a collection of data. IR systems are interface between users and data repositories, databases, internet, digital libraries, right? So this sounds very, very familiar. So I hope that's kind of the theme that you guys are getting to, of what we now modern days call LLM and chatbots, okay? So let's do some comparison of search versus LLM. So first is user experience. So the user experience for search is guess the user intent from a search box of keywords, right? Typing in a bunch of keywords. Retrieve links to the documents, the website, and list them in an order of relevance, right? For LLM, it's guess user intent from a chat dialogue. At least that's the current most popular manifestation of LLM. Retrieve documents and merge them and rewrite them in plain English. But at the end of the day, they're very similar. Algorithms. So back then, we were doing naive Bayes, k-nearest neighbor, clustering, cosine similarity, SVMs, Markov, NLP for different types of matches. And the hardware of choice was CPUs. Fast forward to now, you know, we talked about deep neural network and the Nobel Prize that was just awarded there. The famous Google Transformer paper back in, I think it was like 2018, that revolutionized modern AI. RAG, which is just a fancy term for search. Search augmenting it with LLM. Vectors and embeddings, another popular thing now, but I think it's just rewarding. We had vector databases and columnar databases back in the days as well. And the big difference with hardware is we use GPUs now, thanks to NVIDIA and Jensen Huang. And in terms of technology comparison, back then we used a lot of both open source as well as proprietary off-the-shelf software. Nutch, Lucene. I had the opportunity to work with the creators of Nutch, Lucene, and Hadoop at Yahoo, Doug Cutting. Doug Cutting was hired by Yahoo in 2005. Mahout was probably one of the OG machine learning libraries that if you guys did machine learning back in the days you used. Everybody knew how to do R. Back then, R was the language of choice. Before, I think software engineers took over and go, all right, let's shift you guys to Python. Python, at least, is a little bit more maintainable in production and scalable versus, hand-spun R algorithms. Like I said, we use Oracle, unfortunately. Who here has heard of Berkeley DB? Raise your hands. Yeah, we were big user of Berkeley. That was Sleepy Cat Berkeley DB. Big users of that. I mentioned Mod Perl and regex. I think at the end of the day, it's just pattern matching, right? Whether it's information retrieval or LLM, pattern matching. What's the best pattern matching tool out there, and still is? Regex. Nowadays, or more recently, we've done, PyTorch, Pandas, TensorFlow. NVIDIA has their own TensorRT. Amazon has recognized for ImageRec. And then we also have commercial big data warehouses like Snowflake, open source like Spark, DataStax, Pinecone, open source vector, and open source open weight LLM like Llama 3. Okay, ingestion and transformation, very similar. Back then, we're crawling an entire public website and generating index for information retrieval. Nowadays, still crawling both public website as well as you could do private LLMs, so private data repository, and then generating large language models, multi-level graphs weighted by probability for answering. Okay. It's size always matters. Back then, it was comparing the Google, Yahoo, Microsoft wars were comparing the size of index or number of pages crawled. Right? Google crawled 20 billion, Bing crawled 18 billion. Nowadays, you hear about LLMs is the size of the language models. Right? The bigger, the better. And of course, that's all helped facilitated by GPU, floating point, parallel floating point processors. Hit and miss. So back in the days, it's precision and recall, and this is a very famous Venn diagram of precision, explaining basically what precision and recall is. And precision and recall is just basically the percentage of retrieved document that is accurate versus total available document within your system. So if you have a precision miss, right, it's just a search failure. Nowadays in LLM, it's called hallucination, right? So there's a whole marketing and a VC effort to humanize LLMs, and they call it reasoning and hallucinations, but it's the same technical terms that we were very acclimated to back in the days. Agentic is the huge buzzword these days. I call it just cron jobs. That's what we had back in the days, right? And I'm sure most of you guys still use cron jobs back in the days, right? Your secret sauce is in your Etsy cron tab, right? And it looks like that. Run something hourly, and of course you always put a random number at the beginning, so you don't have everything start at the 0th hour and clog up your CPU computation. And now it's called agentic, and VCs could justify 10, 100x valuation just by changing the name. I had an old architect at AT&T Interactive YP. His name is John Straw, and he's your typical curmudgeon architect. And one of his favorite sayings is, those who don't use crontab are destined to reinvent it. Can LLM reason? Well, Yann LeCun, the chief scientist at Meta, thinks that AI is dumber than cats. So do a Google for that. It's a nice paper he wrote out about a year ago. He softened up his stance a little bit, but I think that's probably because Zuckerberg is telling him, hey, we're investing a lot, writing a lot into LLMs. However, at the same time, Jan is still a big proponent of meta AI. And one good thing I think that Facebook has come out, and we could say all the horrible things about Facebook and social media, but one good thing that's coming out of Facebook and Meta is that the Meta AI is open weight. And I think I'll go a little bit more into that, but Jan is a big proponent of open weight LLMs. Can LLM reason? Well, there was an Apple paper that was published less than a year ago, so understanding the limitations of mathematical reasonings in large language models, and the conclusion was no. Terence Tao, who is many considers the greatest living mathematician right now, and a UCLA professor, basically says OpenAI 01 is a mediocre and competent research assistant. It does not reason. It is not a source of knowledge it is not a source of knowledge or ideas, but really a useful glue. And I think that point, glue, is important. It is a very useful, powerful glue, and I'll go to that a little later. Okay, so it says, yeah, we need, humans and AI will always complement each other. I love this meme, right? Especially if you're in the data field. There's no AI, it's just somebody else's data, right? There is no code generator, it's just somebody else's Stack Overflow. Another good meme I enjoy, right? When you're working in the field of data, bad data is the bane, right, of existence. So here you have you have crap in data, it's plus machine learning, it's crap. Crap data plus artificial intelligence is sparkly crap. Crap data plus generative AI is unicorn crap. And crap data with agentic AI is little turdlets. Okay. But I am not going to downplay LLM. It is a very powerful tool. And I'll give you a great anecdotal story. So after AT&T Interactive, I joined a company called Chegg. Who here has heard of Chegg? Especially, I think, if you've recently been in college, textbook rental. Chegg is based up north. They acquired a company here called Cramster. And Cramster was founded in 2000 here in Pasadena. It's like one of the original SaaS. In 2000, they were charging $20 a month. All you could ask questions. You could even take a picture of your question in your textbook. And we had about 100 subject experts in India that answered your question in 5 minutes or less. It could be from basic math to quantum mechanics, multi-step solutions, 5 minutes or less. So when I joined Chegg, I ran the Cramster office. They just acquired Cramster. So my job was to integrate Cramster into Chegg, which took a year. Cramster was written in .NET, unfortunately. Chegg at that time was written in PHP, which was also quite unfortunate at that time. We decided to throw both away, and we at that time, Groovy on Grails was pretty fun. Who here has used Groovy on Grails? Yeah, probably bad decision now, but back then it was pretty cool. So we rewrote the whole Chegg and Groovy on Grails. So Chegg Homework Help was actually integrated here in Pasadena on Lake by my team. And I left shortly thereafter. Chegg IPO'd, and Chegg Homework Help kind of led the way in its valuation, and it went up to over $100. Fast forward to 10 years later, about 3 years ago, when ChatGPT 3 came out, the stock just tanked, right? So I could say I was in an industry that disrupted the old academic industry, and within 10 years to see it get disrupted again by AI. It's an amazing time we live in, where you see the disruptor becomes the disruptee within a decade. I know this is more of a technical crowd, but I'll quickly go over the economics of LLM and why I don't think it's sustainable, right? It costs $100 billion to build the next AI factory, right? So only the big players could really do it. The Microsoft and OpenAI are planning to build one. Wall Street and Wall Street's full creating wonderful new financial instruments and debt instruments. So they created an $11 billion debt market for AI groups to buy NVIDIA chipsets. OpenAI, Google, Anthropic, they're seeing diminishing returns on the new model. They say like O1 is only incrementally better than GPT-3, and then O2, I think is their next name, is only minusculely improvement compared to the 10x in price that it cost to build. ChatGPT just announced an agent service that they're going to charge $20,000 a month and try to monetize. Yeah, good luck there, right? What I learned with search is search monetization is just arbitrage. At the end of the day, we're just traffic. We're just arbitraging traffic, trying to find supply and demand, traffic versus demand advertisers who are willing to pay for eyeballs or traffic. LLM monetization, I think eventually it will be arbitrage as well. Because right now, I don't think the subscription model is sustainable, right? How many people here actually pay $20 a month for ChatGPT, right? A few, but if you add that up, right, you gotta pay for Copilot, you gotta pay for this, you gotta pay for that. Pretty soon it just becomes like the whole cable bundling to streaming war, and then all of a sudden I'm paying for Netflix, I'm paying for this, and now I'm paying over $200 a month for all these services. I also think consolidation of AI companies is inevitable, just like search. So this is an old flashback. Who remembers all these old search companies, right? Yeah, Ask Jeeves was actually a big presence here in LA. Yahoo bought half of these. Google bought the other half. Yahoo bought Alta Vista and to me, Overture, of course. Right, so eventually the consolidation right now, Google's won the game. Google owns over 80% of organic search. 80% of their revenue is based on AdWords or AdSense, and mobile search even a higher number. But we'll see with DOJ. They're finally cracking down after 20 years. They're finally saying, hey, they're a monopoly, but it may be too late. So I think ditto with LLM, right? There's just so many flavors of LLM right there, and it's hard to keep up. I think in terms of consolidation, I think only the big ones, those with the capital to continue to build, LLMs, new models that cost hundreds of billions of dollars, or data centers, hundreds of billions of dollars of data centers that to build tens of billions of dollars worth of new LLMs. I think only the big three, and China is kind of came out from left field with DeepSeek, so it's very interesting what China is doing. And will that eventually become the holy grail of AGI? I don't think so. I don't think LLM. I think LLM is one component of eventual AGI, but it's definitely not the path to AGI, unlike what VCs and marketing has told people otherwise. So open source model, like I mentioned before, with what Jan said about Meta AI is changing the game, and now with DeepSeek. With the latest DeepSeek benchmark, sorry, the links, you obviously can't click it, but just Google a DeepSeek benchmark. They've been outperforming. LLM will eliminate all closed source weights, LLMs that cannot outperform. That's Jan's quote. Open source models are surpassing proprietary ones. Okay. So what are lessons in search that could be applied to LLMs? So LLM is a powerful tool that integrates with systems that we are used to. It is not AGI. So I went to a talk earlier this week, and that was a quote from that talk. And it's just interfacing with existing tools that we've all been using. That's all it is. So it's what engineers do, right? We're integrators. So we're just integrating new systems and presenting it in a new way. Data cleanliness and data quality is king, right? So the old saying, garbage in, garbage out, applies to software engineering, applies to search, applies to data warehouses, applies to LLMs, okay? Search is very good at joining index data, right? So if you ever play with any of the search engines, whether it's open source, Lucene, Solr, now Elastic, indices are huge, right? And if something is broken, search is broken, it's not retrieving the right thing, you re-index. But you only re-index off of structured data. LLM, however, is good at joining unstructured data. And I think that was an aha moment for me maybe a year ago when somebody explained that to me. It's just, you don't need to structure your data anymore. You don't need to put it into a tabular format. It's great at pulling unstructured data from all parts of the world and internal repository and performing this miraculous join on it, right? And to non-technical people, it seems like it's like magic, right? But it's just a join. It's just joining what seems to be unrelated data together through correlations, through statistical correlations, and representing it as human thought, original human thought or original human language. But at the end of the day, it's not original. It's still existing data, just joined together in a different manner. And as I mentioned with regex, it's just pattern matching and data interpolation. LLMs cannot extrapolate. If LLMs could extrapolate, it could predict a stock market, right? we should all be sitting at home and not working anymore if we could build an LLM that could predict the stock market. So it cannot extrapolate. It can't predict the weather. It can't predict the stock market. It can't even predict a pretty basic system right now. At least there's not enough computation power to do it. So maybe if we increase the computation power, I'll also talk about simulation later on, increase the simulation capacity. It may be able to do better with prediction. So to me, at the end of the day, agentic AI is just a cron job, plus awk, pipe to sed, pipe to regex, plus a popular GPU cluster. I know I'll keep you command line folks happy, but that to me is what it's a little bit of window dressing, but really nothing much has changed. Okay, so what's next for AI? I think multimodal LLM is the next killer app. And I wrote this 6 months ago, actually presented it 6 months ago. Now we're already seeing multimodal. And by multimodal, I mean not just text chat. So voice chat has become, the latency for voice chat has decreased drastically. Who's seen a demo of Sesame? Yeah, incredible. Go to sesame.com. The voice-to-voice latency now of Sesame, voice to go to text to go to LLM, back to text, back to voice, over the web, because you don't have to download anything on Sesame. It's about 200 milliseconds. It's incredible. So again, it's something that almost seems like magic. Many people think it is magic, but it's just technology and computation power and high bandwidth interconnect. Spatial intelligence. This is a relatively new term, but it's thinking beyond LLMs, which really think about LLMs. It is a one-dimensional stream of patterns that you feed into a model, and then you retrieve out new patterns from your model. Well, a lot of folks think to talk about AI, you gotta think multi-dimensional, you gotta think spatial. And robotics is on the cutting edge. And even Jensen Huang says with NVIDIA, investing a lot in robotics. My son, he's in our high school robotics team. They just had a rollout this weekend. And they built it's like a $12,000 robot. My son's head of CAD for the team. We got a CNC machine. We got 3D printers at our school. So our school is pretty well funded. And it's also sponsored by JPL and Boeing. And they're building stuff. There's computer vision. They're doing deep neural network. And they're doing all this in high school, right? What were we doing in high school compared to what the resources that kids have these days? So I think it's great that you have kids that are exposed to spatial intelligence already that will lead the way to AI robotics. Who has heard of Fei-Fei Li? Fei-Fei Li is considered one of the godmothers of AI. And she actually did her PhD here at Caltech. Who here has heard of ImageNet? Right, ImageNet is the basis of computer vision, of modern computer vision. So Fei-Fei Li created ImageNet. But before that, while she was at Caltech, she created a 100-node ImageNet. Because, back in Caltech, and this is back in, I think it was early 2000s, right? Computation power is nowhere near it is today. So Caltech 101, it was named after a course that she was a postdoc in. Caltech 101 is the original ImageNet. And so if you Google for Caltech 101, you can see the paper that Fei-Fei wrote. And so she now has a startup called World Lab. I think she raised about 200 million. Also talking about spatial intelligence and talking about how, perception. She also, if you read her book, she talks about the human eyes is the closest thing to artificial intelligence. Because if you know about evolutionary biology, right, the eyes, the ocular sensors came from a neural fold in the blastula in an embryo. And so it's basically part of your brain. And so I think that her thesis, the next step in artificial intelligence, is to be able to connect what the human eyes see and processes with the brain. Simulation. So in my previous life, I actually did HIV lab experiments, research at City of Hope. And the famous term is in vitro, or something that you can experiment in a petri dish. Then if it works, then you move into in vivo, first starting with lab rats, and eventually through clinical trials with humans. The transition from in vitro to in vivo is the huge thing. And 99% of experiments work in vitro, but does not work in vivo. And in vivo, especially for humans, requires going through clinical trials, and that requires years and years of experimentation, right? So of waiting and experimentation. So what if you could shorten that? And that's where in simulo or in silico comes into play. If you could simulate in vivo in the silicon chip, you could shorten that test cycle, right? From years to weeks to days to hours to minutes, even seconds. And I think that is where you test your theory. You keep testing your theory, and you test your LLMs, your LLM output in this simulation to basically to put in a feedback loop, right? So I think that is a huge area of research that will lead to AGI. Causality. There was also a Caltech paper talking about how do you compute causality. So, in if you guys seen Matrix 2, unfortunately not as good as Matrix as the original, but there was a whole spiel about causality, right? What causes a human to do what they do. If you can compute that, I think that's also a great breakthrough. Finally, Satya, CEO of Microsoft, says, self-claiming that some AGI milestones, that's just nonsensical benchmark hacking to me. The real benchmark of LLM is the world growing at 10%, so productivity, really causing productivity growth. That to him is what LLM is. And I'm always asking, when is the H200 chipsets coming out from NVIDIA, which I last heard is in May or June. That will, of course, increase the computation power of GPUs. So that's all I got. Questions? I know this is the last talk, and we got the keynote, so I'm just holding you guys from keynote and home.
You mentioned how LLMs aren't AGI, which is pretty clear, but I'm curious how we'll know when we get there. It seems like you were holding up as a standard that it couldn't accurately predict the weather or the stock market, which we can't really do either. So what is, what is there a test for what could be considered AGI besides like something subjective like a Turing test?
Yeah, I was going to say Turing. As I mentioned with simulation, I think simulation could get us closer to predicting the weather, predicting the stock market. But I agree with your point that AGI does not necessarily mean predictability of complex systems because, yeah, humans can't do it anyways. Yeah.
A couple of things. Did you catch the keynote yesterday, the kind of dagger which seemed to kind of wrap CI/CD environment around running LLMs?
I stopped by the Dagger booth.
Oh, good.
But
Yeah, so I thought
did
that was pretty cool. And I'm just really kind of on the end user side. But it seemed like what I was kind of looking for was real easy ways to do kind of the RAG thing, the augmentation, where you take your personal data, throw it on top of an LLM, and then can spin something up to ask questions or have other people ask questions about this knowledge of data. But kind of what I was getting at with or one other interesting thing, it seems like the DeepSeek approach, they were able to just kind of with alternative approaches be able to create a model for at a much lower cost. Do you think that's real, or is it like a cold fusion thing, or?
Yeah, 2 points, both really good. Your first point on RAG, kind of creating your personal LLM, that's actually parallels what search, one of the holy grails of search is to create a personalized search experience. And personalized search experience is all about context. If you have context, you could guess user intent much better. Ditto with LLMs. So whether it's through RAG, whether it's through having a personalized retrained LLM that's based on your context, that'll provide a better experience. And then to your second point, sorry, what was your second? DeepSeek.
Alternative approaches, reducing the cost of doing the training for my personal.
So there was a lot of hype that came with DeepSeek. Oh, they built a new LLM, a new model in less than $10 million. So all that is BS, right? They rode on shoulders of giants, just like all research does, right? They rode on shoulders of giants. They used open source LLMs. They used Meta AI. They reverse engineered ChatGPT's o1. And so I think their secret sauce is they were able to compress their model from billion nodes to like a few hundred million nodes, sub-100. So it's more about compression. And if you think about it, LLM at the end of the day, it is a form of compression. It's be able to compress the world's data into a much smaller model that you could do input and output on. But good question. Aachen said.
Hi, I have two questions. One is just about Pasadena. How do you view the mountainside tech versus Silicon Beach? And I'm not sure if that shift that was supposed to happen really happened, and etc.
Yeah.
The other one is more about the talk. Is you mentioned unstructured data. I'm still not sure about where, like, analytics, tabular data, decision trees are going, and can LLM help there with maybe tagging, and will we still need that forever, for real, making business decisions, etc.?
Oh, good question. So your first question is about Pasadena and tech. So obviously I'm a little biased. I've been here since 2001. I think Silicon Beach has kind of stolen a lot of our thunder in the last 10 years. But I think your hardcore tech folks are still here. Caltech, JPL, Pasadena Art Center, amazing center. And I think a lot of us older engineers who have families, who have kids, who want quiet tree-lined streets and less traffic, and we don't care as much about the beach and lures of the west side or here. So there's still a lot of talent here. So I'm still very bullish about Pasadena Tech here. You mentioned analytics. So analytics is definitely a very lucrative, big field, right? Especially in enterprises and business. And I think LLMs and creating chatbots that could help. At the end of the day, analytics is generating reports for business insights, right? That you could basically distill down just mountains and mountains of data to something that a non-technical executive could say, aha, I see a pattern in there, and I can make a business decision or take an action based on analytics. Well, that's what LLM is very good at doing, right? Distilling giant amounts of data and giving you the TLDR that basically exposes a pattern or a trend, then you could apply some human thoughts to it and make a decision on. So I think LLMs in the field of analytics will definitely help drive that. I think you had a question on right here on this side.
I'm wondering, are there any lessons pertaining to kind of security threats in the classical search space or in classical adversarial ML that you think are relevant to the kind of LLMs of today? Because this kind of shift from structured data to unstructured data, where instructions and data kind of get all mixed up, and the stakes are much higher compared to, say, classical search engine optimization versus prompt injection against your LLM, which can now take independent actions as an agentic system. Just curious if you have any thoughts about how we deal with security in this new paradigm.
Security is definitely super important here. Yeah, even more so with LLMs. Yeah, so actually you bring up a good point. It's like, what is the SQL injection analog of LLM? How can you, and actually I've seen that where they call it like poisoning LLMs, where people actually poison or train an LLM to come up with fake news, fake data, or fake results as a result. So I guess they call it LLM poisoning. But I think at the end of the day, security applying to search, applying to data warehouses, the same thing applied to LLMs. You basically have to have engineers. Your scientists and your engineers and your trainers think security first. So it's the whole premise of shift left. Don't leave security to the InfoSec folks at the end, trying to lock up a really crappy or insecure system. You got to think security from the get-go. So whether it's access, encryption, all the things that you do to secure your software, to secure your current data sources, you have to do the same with LLM. I don't have the answer. I'm not a security expert, but I think the security experts that do the same thing right now with software and do the same thing with data sources, they have to be similarly applied with the same rigor to LLMs.
I guess with like traditional kind of databases, there's say like parameterized queries to clearly separate your instruction and data, but then when it comes to prompt injection, there's kind of no clear way to delineate the data and instructions. So I guess like with that in mind, do you think that the security limitations of LLMs will kind of prevent them from being useful for any real world purposes just because of the kind of probabilistic chance of failure, especially in kind of high stakes settings?
I think there's enough money invested in LLMs where people will come up with solutions. I think they have to, right? To your point, they have to. Otherwise, you can't trust it. So I don't have the answers, but I think somebody does, smarter than me does. Or maybe Cho here does.
So I was here last night at game night, and there was some security folks I was sitting with, and we were chatting over dinner. And so some of the things that they have seen, these security experts, a lot of these prompt injection attacks are usually built around like misspelling. For some reason, when you have whatever input from the user and some words are misspelled a certain way, those tend not to get caught. And so usually that will actually elevate your user status above to say a super user or admin status, then you can take over the LLM for whatever needs that you have. And so I think there are people like red teaming this all the time, so they're finding out ways, and obviously different models have different vulnerabilities, and so I think it will take a lot of resources and also good effort upfront to make sure these models are secure before they get released to the public.
We got time for one more,
I think I saw a question. I think
and then I'll be outside. We could talk to me if you have a follow-up you want to ask.
Okay, hi. I was just kind of wondering if you could elaborate more on what you meant by human eyes being the next step for AI.
Talk about human.
Human eyes being the next step for AI.
Well, it's so I have a biochemistry background. Went through. There's a term called phylogeny recapitulates. I forgot. My biochemistry background is like over 25 years ago. But if you look at evolution of human biology, the eyes is the very first things that form out of the neural network of the brain, right? So people are when they talk about the human brain and AI, a lot forget about the eye. And so Fei tackled AI first through ImageNet, right? And because I've read a paper where they say that a human eye can recognize an image and actually post recollection, whether it's like facial recognition, I could recognize your face, before even making a round trip to the brain, meaning there's maybe even some thinking going on within the eyeball itself. So I think what the eye is, it's literally a window to the world, to the real world. And AI by itself, LLMs, just feeding through text stream base is not enough. I think the information you want to process from real world input, looking from images, looking for videos, I think that is a closer step to AGI. Okay, so thanks everybody for the talk and being a great audience. I'll be outside if you guys want to ask any more.